Introduction to Statistics, Chapter 3, Numerically Summarizing Data, Section 3.1, Measures of Central Tendency. The mean, or arithmetic mean, is computed by finding the sum of all values of the variable in a data set and dividing by the total number of observations in the data set. Whether you have a sample or a population, the mean is found the same way. The difference is in the symbol notation used to describe the mean. If you recall from Chapter 1, a statistic is a numerical summary of a sample, and a parameter is a numerical summary of a population. The formula for finding the mean of a sample. X bar is the symbol for the mean of the sample. Sigma of xi is the sum of all values for the variable x. N is the size of the sample. So x bar equals the sum of xi divided by n. It's the sum of all the x values divided by the sample size. For a mean, it's the same thing, except for this time we use mu, the Greek letter, for the symbol for the mean of a population. You have the sum of xi, sum of all values for x, and you have capital N for the size of the population. When working with the mean, remember the following. Use the symbol x bar to represent the mean of a sample. Use the symbol mu to represent the mean of a population. If you are given x bar, you are working with a sample. If you are given mu, you are working with a population. You need to know whether you have a sample or a population you're working with. Now, find the mean for a set of data. Option 1, you could do it by hand. You could use a calculator to add all the data values and divide by the total number of data values. Remember to use the correct symbol, x bar or mu. Now, working by hand isn't bad if you have a small set of data. If you have a large set of data, then you're going to want to use technology. So option 2 is use StatCrunch. First, load the data into StatCrunch. Click the icon in upper right corner of the data and choose Open in StatCrunch, and it will automatically put your data in StatCrunch. Second, select Stat on the top menu, highlight Summary Stats, and select Columns. Under Select Columns, choose the column you wish to summarize. Under Statistics, choose Mean, and then you would click Compute. We're going to look at some examples now. I've already entered data into StatCrunch. So, going through the process, if I want to find the mean, I would click on Stat, Summary Stats, Columns. Now, I pick the column I want to find. Let me pick column 3, let's say. I want to find the mean of column 3. So I pick column 3, go down here under Statistics, Mean, click on Mean. You notice now mean shows up over here on the right side. Variable 3 showed on the right side. Now I just hit Compute, and it tells me the mean of column 3 was 5.91666. Now, the other nice thing about this is if I wanted to, I could find the mean of all 4 columns. Just click variable 1, hold the control key, variable 2, variable 3, variable 4. Go down under Stats, hit Mean, click Compute. Now it gave me the mean of each one of the columns. So you can do more than one column at a time for the mean. All right. Now we want to talk about the median. The median of a set of data is the value that lies in the middle of the data when the data is arranged in ascending order. Your author uses a capital M to represent median. If a data set contains an odd number of data values, the median will be the value in the middle. So an example, find the median of the following data set. First, you would take the data set and put it in ascending order. Second, count how many there are. There are 7 data values. So 7 divided by 2 is 3.5. So that means there's going to be a value in the middle, which means I'm going to have 3 values on the left, 3 values on the right, with one value in the middle. And that value in the middle becomes your median, which in this case is 256. If the data set contains an even number of data values, the median will be the average of the middle two data values. So in this case, another example, I just added a number to my list. So I put it in ascending order. There are 8 data values. 8 divided by 2 is 4, so there's going to be 4 on the left, 4 on the right. But now, there is no data value in the middle. So what I have to do is find the average of the middle two data values. So I find the average of 234, 256, which is 245. The median does not have to be a value in the data set. This is an example where it's not. Okay, the median. Finding the median for a set of data using StatCrunch. Same as before. Load the data into StatCrunch. Select Stat on the top menu, highlight Summary Stats, select Columns. Choose the column you wish to summarize. But this time, under Stats, we're going to choose Median instead of Mean. And then we click Compute. So if we go back to our examples that we used before, now this time, if I want, I'm going to click up here on the top menu under Stat, Summary Stats, Columns. Now I'm going to click all 4 at the same time. So there's 1, hold down the Control key, 2, 3, 4. Now I want to go down here in Stats. I see N, Mean, Variance, Standard Deviation, Standard Area. So I'm going to click over here on this little bar and scroll down until I find Median. Click Median. And now you would click Compute. And in this case, I got the median of each one of the 4 lists. So median is very similar to finding the mean. Now next, comparing mean and median. A numerical summary of data is said to be resistant if extreme values, very large or very small values, relative to the data do not affect its value substantially. The mean for a set of data is not resistant. For example, if you had a set of values and you took one of the values and made it an extremely large value, that's going to affect your mean. It's going to raise it. Or if you took one of your lower values, made it a very, very small number, it's going to lower your mean. So the mean is non-resistant. But then again, the median is the number in the middle. If I take one of the upper numbers, make it extremely large, the median stays the same. Or if I take one of the lower numbers, make it very, very low, the median stays the same. So the median is said to be resistant. Comparing mean and median. The shape of the data distribution, skewed left, symmetric, skewed right, may be determined by looking at the mean and median. If the mean is less than the median, the distribution will be skewed left. So if we look at this, the mean is less than the median, we have our data skewed to the left. If the mean is equal to the median, the distribution will be symmetric or bell-shaped. So the mean equals, so they're both right in the center, and it's bell-shaped. If the mean is greater than the median, the distribution will be skewed to the right. So this time the mean is greater than the median, so we have skewed right. So we have 3 options: skewed left, symmetric, skewed right. And it all can be determined by the mean and median. Okay, let's go back to our StatCrunch. Same problems. This time I'm going to find the mean and median at the same time. So if I hit Summary Stats, Columns, I pick, let me just pick the second, third, and fourth this time. Now I'm going to pick mean, but I'm also going to drag this bar down, hold down the Control key, hit median. Now you notice over here on the right I have mean and median both showing. Now I hit compute. Now if I look at my list here, In the first case, the mean was 2, the median was 4. So the mean is less than the median. So we could say that that would be skewed left. The second one, variable 3, you notice the mean is greater than the median. Since the mean is greater than the median, we would think skewed right. And the last one, the mean and median are the same, so we would think that it would be symmetric or bell-shaped. Well, let me go back to something and show you. If I would go under graph and I would hit a bar plot with data, if I pick variable 2 and just compute, this is what variable 2 looks like as a bar graph. And if you look at this graph, it is skewed to the left. And that's what that meant. The mean was less than the median, so it's skewed left. Okay. Now, if I go under my options, if I change from variable 2 to variable 3, hit compute. Now you notice I'm skewed to the right. And if you notice in variable 3, the mean was greater than the median, so we got skewed right. And if I go back and edit, this time pick variable 4, compute, you notice the mean was equal to the median, and if you look at this curve, it is bell-shaped or symmetric. Okay, so that's how we can use the mean and median to get a description of the data set, whether skewed left, skewed right, or symmetric. All right, now we want to talk about the mode. The mode of a data set is the observation or observations that occur most often. You have 3 possible outcomes for the mode of a set of data. You could have no mode. That means every observation and data set occur the same number of times. You could have a single mode. That means one single observation in a data set occurs more often than any other observation in a data set. You could have multiple modes. 2 or more observations in the data set occur more often than the other observations in the data set. So some examples. If we look at example 1 here, this is an example of a data set with no mode. If you look, every number occurs the same number of times, 3. So our answer would be no mode. Now example 2. This is an example of a data set with a single mode. If we look at 1, 2, 3, 4, 5, we notice that number 2 appeared 5 times, which was more than any of the others. So 2 would be the mode. Example 3 is an example of data set with multiple modes. If we look at this, looks like number 1 appeared 6 times, number 3 appeared 6, and they're both more than the others. So the mode in this case would be 1 and 3. Now, finding the mode for a set of data using StatCrunch. The steps are going to be very similar to what we did for mean and median. Load the data into StatCrunch. Select Stat in the top menu, highlight Summary Stats, and select Columns. Select the column you want to summarize. Under Stats, this time we choose Mode, and then you click Compute. Now, your answer may be no mode, a single observation listed, or multiple modes. If you get multiple modes, you will need to create a frequency distribution table for the data as you did in Chapter 2 to find the mode. So let's go back to StatCrunch and look at our examples. Okay, so in this case, if we want to find mode, I'm going to hit Stat, Summary Stats, Columns. Now I'm going to pick all 4 columns. And now, when you get down here, statistics, mode is the very last one. So you got to get on this little bar, slide it all the way down. Mode is at the end. Now I compute mode, and you notice variable 1, this first column had no mode. Okay. Variable 2, 4 was the mode. Variable 3, 1 was the mode. Variable 4 was 4. Okay, now I wanted to get multiple modes here. So let me go back over here. Let me go to variable 4 here once. In variable 4, let me hit let me add a 5. Let me add a 5. Okay. Now if I go under my options, if I edit, and I only want variable 4, I want mode. Now you will see it comes up multiple modes because there's more than one mode. I added a 5 to the list, I got a different mode. So, since I don't know what it means, I could go under graph. I shouldn't say, I should go under stat, tables, frequency. Pick variable 4 and click compute. Now if I look at my frequency table, okay, I actually got frequency and relative. If you look at 1 was 1, 2 was 2, 3 was 3, 4 was 4, 5 was 4, 6 was 2, 7. So in this case, my mode's going to be 4 and 5 because 4 and 5 appeared more often. Let me go back in here because I didn't want both. I just wanted frequency. Makes it a little clearer if you just look at the frequency. So in this case, 4 and 5 appeared 4 times, which is more. So that's why multiple modes showed up over here. Then we got to make our table. So once again, running through that table, you would click stat, tables, frequency. Click the column you want, variable 4, click frequency. Click compute. And now you can look at the frequency table to decide which ones occurred more often whenever you get multiple mode. Okay. And that's the end of section 3.1.